Welcome back to Physics 142. We've been discussing electricity and electric fields, electric potential, and circuits, and now we're up to the point of the course where we're going to sort of wrap up electric interactions and we're going to move into magnetic interactions and magnetism. So this video is going to serve just as a brief introduction to magnetism, and I want to just compare and contrast electricity and magnetism. Think about just a couple of differences with magnetism versus electricity. So magnetic phenomena are all around us, right? You have magnets on your fridge. There are magnets on this whiteboard. There are magnets in my phone, which is recording this video. So we have magnets all around us, and the magnetic phenomena have been observed for thousands of years. I believe they were first observed in Magnesia, ancient city, which would have been in Turkey. Fundamentally, what's different about magnetism versus electricity? Well, with electricity, we started with the idea of electric charge as a property of matter, that matter has charge as a property. Similar to electric charge, in magnetism, we have a concept of magnetic poles. So magnets have poles, and they have positive and negative poles, just like in electricity. So we'll put here that in magnetism, we have poles, two poles, positive and negative, all right? And like electricity, positive repels positive, and positive attracts negative, right? And negative repels negative. So like charges repel, unlike charges, poles attract each other, all right? So in magnetism, we have poles instead of charges, all right? So we could think of this as like charge, right? Like electric charge. But a big difference in magnetism versus electricity, though, is that these magnetic poles always end up coming in pairs. All right, so let's put this. Magnetic poles only exist in pairs. People have spent a lot of time looking for what's called a magnetic monopole, just a single pole all by itself. And as far as we know, there are consistent with 0 magnetic monopoles in the universe. So magnetic poles always come in pairs. What does that mean? That means that if you have a positive, you always have a negative with it. So if we think about a magnet, all right, here's a magnet. The magnet always will have a positive end and a negative end, that the positive and negative have to be stuck together. If I went and I chopped this magnet in half, all right, so now I have 2 magnets and tried to just get the positive part on one side and the negative part on the other side, it wouldn't work. Each of these magnets still would just then have a positive and negative side. So if you split a magnet, you still have both the positive pole and the negative pole. The poles always have to come together in pairs. I should note that since these magnetic poles can align with the Earth's magnetic field, that sometimes positive and negative are also referred to as north and south poles of a magnet, since that can be related to Earth's magnetic field and sort of Earth's north and south magnetic poles. So that's an important difference between magnetic poles and electric charges. Another important difference in magnetism has to do with magnetic field lines. All right? With electric field lines, when we drew electric field lines, right? If you remember an electric field line, I'll just put this as an aside, right? For electric field lines, right? If you had, say, a positive charge, electric field lines always went out from that positive charge, right? Or they went into a negative charge. So they always began and ended at those charges. But for magnetic field lines never begin or end. All right, so that's a big difference. While electric field lines always began or ended at charges, all right, magnetic field lines never begin or end. So what do we mean by that? Well, they always circulate in closed loops. They always have closed loops, right? What never begins or ends, it's always a sort of a circle or some sort of loop, right? So that means magnetic field lines are always closed loops. So if I wanted to draw some magnetic field lines in a magnet here, right? If I had a magnet here and I wanted to draw some magnetic field lines, I have my south pole and my north pole here, all right? What you get is that magnetic field lines end up being these loops, all right? They loop through the magnet, all right? So they always will reconnect back to themselves, all right? All magnetic field lines always will loop through the magnet, so they never begin or end. They're always these loops. All right. One final difference between electricity and magnetism, and this is the most fundamental difference between the two, all right? The final difference is that while electricity is just fundamentally between charges that could be stationary or moving, magnetism is all about moving charges, all right? Fundamentally, magnetic fields are produced by moving charges. Magnetic fields are produced by moving charges. All right? Never by stationary charges, only by moving charges. And not only that, magnetic fields only act on moving charges. Magnetic fields only act on moving charges. So magnetic phenomena are fundamentally a phenomena of moving charges, all right? They act on moving charges and they're produced by moving charges. Any charges that are stationary or not moving won't produce magnetic fields, and they won't be acted on by magnetic fields. So hopefully this gives us just a little bit of a sense of magnetism and the way magnetism is different from electricity. We'll spend most of the rest of the semester delving into this in quite a bit more depth.